today's Wednesday, isn't it?
Yeah.
So Tuesday's assignment was at the bottom there. Yep, Tuesday. All right, I think we looked at this one yesterday. And we kind of struggled through it, but we got it. And then we did this one. Okay, so let's do this next problem. Given that segment AC and DB are congruent, and we have a couple right angles, we're supposed to prove that the triangles are congruent. So get down what's given and what we're trying to prove. And let's do some thinking before we completely write out the proof to see if in our minds we can get them congruent. I'm thinking that I'm going to write the given down in the form of a proof. So we've got segment AC congruent to segment DB. That's the tick marks up there. That is given. And I think I'll also put angle ABC and angle DCB are right angles. And that's also given. I'm going to orient my screen because it's not writing where I'm pressing. Probably because the power went out. It's off a little bit. Go back to what I was on. It's not what I was on. Okay. I'll open it up again. Okay. All right, so I've just simply got the given information up there. So you were thinking through, what else do I need? So what else would I need to get these triangles congruent by one of our methods? And what are the 5 different methods? Let's make a list on the board. Well, they could be, but we haven't stated everything that we would need. Okay, so what are our methods? Side, side, side. Side, angle, side. Okay, I think I heard angle, angle, side. Yeah, gotta make sure you don't spell a bad word, right? And then hypotenuse leg. So we need to get the combination of information that fits one of those in order to prove this congruent. And the only thing that's been talked about are the things that are marked in the diagram. So we need to probably add a few more details. Let's try and think ahead. What method is this going to end up being? What else will we be able to come up with? Think it's going to be a hypotenuse leg? Okay, so what we've already got is the hypotenuse congruent to the hypotenuse. And we've got some right angles. So what do you want me to add, Connor? Got that? Given.
CB is congruent to CB, like with reflexive property.
Okay, his support sounds good. Segment CB congruent to segment CB by the reflexive property of congruence. Oops, not 4. All right, are they congruent? Is that enough, or do we need to keep going? They mentioned hypotenuse leg. Are you seeing hypotenuse leg in the picture? Okay, now there's always 3 facts that we need. We do have the hypotenuses congruent. We do have the legs congruent. What's the 3rd fact that hypotenuse leg needs? Okay, we need to have actually triangles. And we get there from having right angles. Okay, how do you know that a triangle, what says that a triangle with a right angle is a right triangle? Does that sound like explaining the meaning of something as in a definition, or does it sound like it's what clear up? That a right triangle is a triangle with the right angle. Sound like the definition.
Can we just put a time or angle ABC and DCB are given?
That was given. Yep, I kind of squeezed that in and saved a number. I called it all number one because it was all given. You could have that separated, line one, line two. But we do need to have something more in here before we can say hypotenuse leg, because we have not stated that there's right triangles. But we can get there pretty easy. So we simply need to have in here triangle, not just angle, but triangle ABC and triangle DCB are right triangles. Is that the same thing that the given says? No, it's not. But we have to have right triangles to use hypotenuse leg. What did we say our reason was when we were discussing that? Definition of a right triangle. So besides the actual hypotenuse is congruent and the legs congruent, we have to state that there are right triangles if we're going to use hypotenuse leg. I think we're ready to finish it out. So,
Triangle ABC is ACB,
all right, Connor's got it. Hypotenuse leg congruence theorem. And it would be good to make sure that they matched in the order that that says. Triangle A, B, C, D, C, D, just to verify. Okay. So thumbs up or down if you think you could do that on your own. You could do that on your own? Okay. A few not confident, but there are more that are getting more confident. Okay, got what you need for that sample? Let's find another one. Okay, given angle YZW congruent to YWZ and YXY congruent to VY, we're trying to prove, now there's a lot of triangles in this picture, so we better concentrate on the right ones. We're trying to get XYW. Okay, that's kind of a big one here, so let me draw triangle XYW. We're trying to get congruent to VYZ. I might have to write my proof on the board. Let's see, that's a Y. And a Z. Okay, let's get the givens. Run back and forth a little bit, I think. Should we put the given all in line one, or do you want to use a one and a two? And if you don't like two-column proof, put it in a flow chart or put it in a paragraph. Angle YZW congruent to angle YWZ, segment XY congruent to segment VY. All of that is given. And I'm going to mark it on my picture, YWZ. Now when I made these big triangles, I didn't put point Z on it because it wasn't a corner of the triangle. But realize that's this angle, congruent to this angle. No. YWZ and YZW. And then XY congruent to YV, XY, YV. What else can we come up with? We had this angle congruent to this one, that segment congruent to that one. But we're trying to get this big triangle congruent to the other one. Different color.
These two angles are congruent, I mean, X, YZ, X is congruent to YWV.
This angle?
Yep.
Congruent to this one?
Yep.
Do you have a reason? I think you could get there. Let's see if that's gonna help us. Down in these triangles, Y, Z, X. I think Y, Z, X would be kind of like in the middle here somewhere. So thinking that angle is either gonna be on the outside of the triangle or partway through the triangle. Does that make sense? So I'm thinking, although we could eventually support what you're saying, I don't think it's gonna help us in the triangles that we're working on. Think of things we've studied. I see lots of two sides congruent and two angles congruent. We had some theorem things about triangles that have two sides or two angles congruent. Look through your notes. Look through, you got your book open to those theorems? What's a triangle called that has two sides congruent? Isosceles. Look to see something about isosceles triangles. What's something that we should be learning this chapter about isosceles triangles that would maybe help us? What's that say, Morgan?
If two sides of a triangle are congruent, then the angles opposite the sides will be.
Okay, we've got a triangle, great big triangle that has two sides congruent,
All the
right?
triangles and isosceles.
The great big triangle is isosceles, so what are its base angles? Yeah, the angle, why did that do that? All right, go back. Now I've got it all screwed up. Okay, let me back up here a second.
You know,
I think it went to the wrong slide. Okay, we'll see if I can adjust it again. Okay, so this, maybe I was trying to move it and should have lifted my pen. This angle is congruent to this one because the whole thing is a great big isosceles triangle. With me on that? Okay, so where are those angles in our triangles? Well, this one is YX, either Z or W. YXW. So this angle is that one. And then this angle is this one. Notice how that's going to help us angle, angle, side. Angle, angle, side. Okay, so let's try and get the last part there. So what did we have? We had angle YXZ congruent to angle YVZ. I'm using the names from the triangles. What was our reason? What did Morgan read? Not definition. Theorem, if you keep going. Okay, so isosceles triangle theorem. That if two sides of a triangle are congruent, there's two angles congruent. There was a pair of angles, a pair of sides, a pair of angles. In the triangle, what arrangement is it? I think we're ready for the finish. So we have triangle XYW congruent to triangle YVZ. X. VYZ. VYZ. Trying to match them up and speak at the same time. And what's our reason for those triangles being congruent? Angle, angle, side. That one had a little bit harder theorem involved. All right, how many examples do you want before we start working? Do you want one more or start now?
One.
Okay, some said one more. Let's take a look at one more quick. All right. All right, here's the one. Segment PN bisects segment MO. Segment PN is perpendicular to MO. We're trying to get the two triangles MNP and ONP congruent. So as I read through that, I'm kind of looking at the picture, seeing which ones. This picture looks easier than the last one. It doesn't have the overlapping things. what's it mean to bisect a segment? If I pull the first part, segment PN, you gonna cool us off a little?
Yeah, I'm gonna try.
Okay, we are a little bit warm. Bisect segment MO. Since I believe we need to think about that, I'm just gonna put that given and then we'll put another one in a little bit. What's it mean to bisect a segment? Bisect a segment. What's that mean, Taylor? Cut the segment in half. Okay, so we're cutting segment MO in half. What's that gonna make? Two congruent segments, because we know what a segment bisector is. We're using the definition of segment bisector. Had we flipped a switch?
We'll see if it works.
All right.
Hopefully it does.
We'll hope so, okay. All right, so we wanted to say segment MN congruent to segment ON. Okay, segment MN congruent to segment ON. There's one pair of sides congruent. Let's pull the next given down and see. Segment PN perpendicular to segment MO. Given. I'm not feeling cooler yet. Okay, what's it mean? If PN is perpendicular to MO.
Makes 90 degrees.
Makes 90-degree angles, okay? So we could say this is we could either say 90-degree or right angle. I think we're gonna wanna say right angle. So name that one as a right angle, name this one as a right angle. And then we're gonna have to think what the reason is here, Michael. So angle MNP. MNP and angle ONP are right angles. Okay, how do we know that?
Perpendicular bisector.
Okay, I don't think, it didn't say bisector. I guess we could put that together. It's really just the perpendicular part. We already did the bisector part. So perpendicular, is it a theorem about perpendicular? It's just the definition. It's just giving us the definition. Definition, so what it means. Definition of angle bisector. No, that's not what I wanted. Definition of perpendicular is what I wanted. I was thinking about his bisecting. Now those right angles could do two things. Remember the problem a little earlier that we had right triangles to do hypotenuse leg? You think as we finish this, is it gonna be hypotenuse leg? Think what else we're gonna come up with. What do you think it's gonna be? Looks like it's gonna be side angle side. Yeah. So those right angles, we need congruent to get our angles that are congruent for side angle side. So I need the thing that said right angles are congruent. Look in page S82, S83, where is the thing that says right angles are congruent? Right angles are congruent. Right angles are congruent. It says exactly that.
Right angles congruence theorem.
Give me a number so they can find it.
263.
263. Right angles, that's the number of like the section, the number of the theorem. 263. All right angles are congruent, it says. Right angles congruence theorem. Right angle congruence theorem. Okay, so that actually gets those angles congruent, which is what we're going to need to finish the problem. Okay, so what have we not mentioned that you are thinking that we need? P.
Segment PN is congruent to PN.
Okay, segment PN, congruent to segment PN. What's your reason, Michael?
Reflexive.
Okay, we We use that a lot. Reflexive property. Oh, I'm feeling some cool air now, are you guys? All right, good. Reflexive property of congruence gets our PN congruent to PN. Okay, we've got sides, we've got angles, and we've got sides. And in the picture, you told me it was side, angle, side. So finish by going triangle, MNP, congruent to triangle, ONP. Reason for the triangles that are congruent, side, angle, side. Congruence, postulate. That one gave us a little bit difference. The right angles or the perpendiculars could be used two ways. If it's going to be a hypotenuse leg, then you need to use those right angles to name right triangles. If you're going to use something like side, angle, side, 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 or side, angle, side, side, no, angle, angle, side, angle, any of these that have an angle in there. If you're gonna use right angles in that, you have to use the right angle congruence theorem to get them congruent, not just right triangles. So the right angles could be used two different ways, depends upon the problem. All right, let's get started on some of these. As I said, there's 8 proofs here that you'll be doing for homework. You need a sheet of paper to do the proofs. I didn't really give you a bunch of space and nice organized lines to write them on. It's time for you to create your own. Sure, discuss some ideas with the neighbor while you're here in class. Is the clock right? Is it, no, it's not 2 o'clock probably. Is it 1 o'clock?
So we put 1 o'clock.
It's, what is 1 o'clock pretty much right
Then
now?
we put
Yeah. And on proofs, yes, you do need the number. I think you need a sheet of paper so we can write big enough that we can maybe be able to read it. So have those problems, have your theorems open, and your Dave's got a good organized desk. Paper, the assignment, the books open. And as you are writing things in your proof, think what I did on the board. I was marking, okay, I said these segments are congruent, I'm gonna mark it in my picture. I said these angles are congruent, I'm gonna mark it in the picture. That way the picture will have marked everything and it's easier to finish the problem as far as what relationship